Hi, my name is Matt Tinker, and this is yet another episode of my rocket stove. Today I set up two pieces of 2.5mm 1/8 inch mild steel plate in my mill because I need to do a series of slots along one edge where it's going to be bolted to the cast iron of the bathtub. The reason why I need slots is because when I put a gasket behind it, it's going to crush it, and the mild steel will slide will need to be able to slide in the slots. Well, about 10 years ago I saved this virtually invisible here big black machine from going from the slow boat to China to be scrapped. It's a folding machine and bends mild steel up to 2.5mm thick with it. I'm only doing a slight bend here because it's for the first of the bath, to follow the first of the bathtub folds. So the pieces of plate that I've been cutting out and started to bend for the bottom edges of to join the bathtub to its base. I'm cutting them out. I've cut them out, drilled them, slotted them all at the same time, and I'm doing the bends for both sides at the same time. So this is the first of, I've got the first bend in, and now I'm going to start bending from here, just using small bites to nibble it round to get it to follow the curve of the bathtub. Okay, so this is the beginning bend of that nibble. I'm not sure that I've got that square. Yes, I have. Nearly. Okay. Okay, so my first nibbles were a bit too closed, so I could go back, flatten them out a little bit, and go on from there. I actually had to flatten it back quite a lot on that first nibble. Right, now that I've got the piece of plate roughly to shape, I'm going to it's not quite sitting there. I'm going to mark the center of each hole with an 8mm bit so that I can then drill it to 6.75, which will allow me to tap, which is the tapping size for 8mm. Cast iron taps very nicely. It taps without any kind of lubrication because of its high carbon content. One of the things that I forgot to mention was that cast iron can be quite hard. This had an area that was hard in the surface, but it should be okay to tap, and I tap using my cordless, which okay, so bolted into place with all the holes tapped, tack and weld around the bottom. I'll leave welding this seam until it's lying on its face, because it's going to be it's always easier to weld lying down. Okay. Both sides of the bathtub are symmetrical, so as I made the second one at the same time as the first, I just mounted it in the same way as I mounted the previous. $17.5 minus 15, that's 2.5. That's 1. It's 12.5 each side. 12.5 or half an inch. These dimensions don't mean anything in particular. The bottom of the exhaust is almost exactly at the top of the firebox. The exit at the top of the firebox exit. I would advise anybody cutting cast iron with an abrasive disc to use a mask. Cast iron dust is extremely unpleasant. It's not in itself dangerous, but it doesn't half roughen up the inside of your nose. I've turned the stove this way up so that I can do what would have been vertical welds in the horizontal position. All of these welds are far better done flat. Do everything flat, and that's what I meant earlier on by lying down. I meant flat. So. Marking out the 8mm bit. drilling to tapping size. Make sure I've got the right bit. Yes, 6.75 millimeters. We could go a bit faster. The cast iron is fine. It's when you get to the enameled section that it begins to get difficult. And the way that I've done it so far seems to work. It doesn't seem to blunten the bits too much. So I'm going to carry on like that. I forgot to drill that one. So, one to drill. You can't hear the change, at least I haven't yet got used to the changing sound that it makes when it gets to the end. There seems to be no warning about it. Test fit. In terms of strength, something like this doesn't need much more than the long tacks that I put on. But obviously, if it's going to be gas tight, then it needs to have to be welded all the way around, which can pose problems because of distortion. But I think this should be okay because it's pretty well bolted down. I'm going to weld as much as I can in situ and then finish the rest. Okay, drilling into the enamel is not likely to be very easy. So what I'm going to do is I'm going to drill it using a masonry bit to break through the enamel, and then I'm going to drill it with a standard high-speed steel bit to be able to drill through the cast iron. The drill bit, the masonry bit, I have sharpened like a high-speed steel metal cutting bit. So I'm going to just drill and tap two, bolt them in place, and do all the way around. Using the pre-drilled holes as a guide, I'm going to tap with the cordless. Right, a couple of bolts. The overall body of the stove is virtually finished, with the exhaust in place, the cover welded to it, and the chimney test fitted. I've been working on the firebox. In particular on the door, which I have not as yet I haven't yet put its hinges on because I don't know where I've put them. I've made the firebox. I've made the ashtray for the firebox, which fits in tightly underneath the door. So this is where I am. This is where I am at the moment, and we'll try